What is IBRL and why is it so important?
For most of the history of blockchain, performance has not been something that's optimized for. But it's how do we make this trusted? How do we build something that'll slowly change the paradigm?
Are you guys writing your own client? Are people expected to migrate to a different client or just change a few configs to be able to join the 𝗚𝗚 network?
The way we sort of are doing this is we are not building a validator client.
You also mentioned you'll have to install a bunch of these switches that HFTs use. So is there a hardware challenge in what you're building?
So the first one is the switches. The second one is the physical fiber in the ground.
You actually need to physically manipulate this fiber links to form this network, right? And what does it really mean? Is it like, are you going to dig trenches in the ocean and then connect it? Or it's like ISPs with access to backhauls?
I would say over the long term, our ambition is that...
Hello. Welcome to another episode of the OnlyDevs podcast. Today we have with us Austin Federa, previously of the foundation, now doing much more interesting things, are in the deep trenches of actual physical and the data link layer of what we know as internet. So welcome to the podcast, Austin.
Hey, thanks for having me on. Appreciate it.
Awesome. I was just reading your paper this morning, and it was so interesting to see a callback or call out to IBRL. So what is IBRL and why is it so important? Like, why is it so important to everything that we do as an industry?
Yeah, so I think there's a good place to start with this, which is that for most of the history of blockchain, performance has not been something that's optimized for. And there's all good reasons for that, right? When you're building a new system from the ground up, which is what Ethereum was, which is what Bitcoin was, the focus is not necessarily on how do we make this scalable out to a world layer, but it's how do we make this trusted? How do we build something that'll slowly change the paradigm? And this is really important, and I don't want to skip over that part, because I think a lot of the time people are like, oh, Ethereum is so slow, it does 20 things per second. And yeah, Ethereum is so slow, it does just 20 things per second, but it laid the conceptual groundwork for smart contract networks. And so IBRL, I'd sort of view as we've had a lot of this, there's Gen 1 blockchains, which are basically Bitcoin, right? Things that are just store of values or simple one asset transfer systems, right? I don't want to put too much philosophical inscription onto what Bitcoin is, because what Bitcoin is changes every few years. It was digital gold for a while, it was store of value, it was all these other types of things, and that's great. One of the great things about crypto is definitions change as the market changes. You don't sort of have a bunch of egos driving, oh, what is crypto at any given moment, right? But that's sort of important. Then you have the Gen 2 things, which are things like, Ethereum really falls into that category. And then you had this sort of amorphously defined third generation of blockchains, which includes everything from, in some people's definition, Polygon to Solana, right? And there's a huge amount of technical differences and ranges between what that is. I would sort of say that today, what we're seeing Solana push the forefront of, what we're seeing Monad and Mega ETH build towards now, although caveat being testnets are not mainnet, we don't actually know what a lot of these systems look like yet. But these capacity numbers that we're looking at are I would say call it real third gen blockchain. I'm not sure that when we're talking about a few hundred TPS and 100 validator set or 200 validator set, that's not really that is basically. Remember when the cell phone companies were calling things 3G plus, right? We didn't really have LTE or 5G yet, but we had all these super fast 3G that weren't really that fast, but were a little bit more, or a DSL falls into that category from an internet technology perspective. There's a lot of really good work that was done sort of, I would say 2019 to 2023, but it wasn't really focused on how do you build systems for performance. It was focused on how do we get performance out of systems that were never built for performance. And the EVM is a perfect example of this, right? Ethereum gives you 30 seconds for a block, and almost none of that's focused on compute. Most of that is Raspberry Pis are kind of slow and they might be running on a phone line somewhere. We got to give a lot of time for block propagation. And so, to get back to your question, what is IBRL and why do we focus on this across the ecosystem now? IBRL is this idea that the only way you make systems faster is you make them faster. which sounds like an obvious statement, but almost no one who's been focused on making blockchains faster has actually been focused on making the blockchain faster. It's all a bunch of additional co-processor, like, oh, we're going to ZK-ify this and suddenly we're going to gain all these performance increases. That is totally true. And you can see on Solana, like ZK compression, which is what state compression and account compression is. It's using zero-knowledge proofs to accelerate a whole bunch of stuff. That actually makes things faster and cheaper. But if you're starting from a base of 20 transactions per second, the scaling factor is quite limited compared to if you're starting the base of Solana or Sui or Mega ETH or Monad or something like that. And so IBRL is all about going back to the base layer to making sure that the stuff at the foundation layer that you're going to build all these other abstractions and programming languages and systems on top of is actually fast. And this really started, I would say, with the Firedancer project. Which was going to, a non-traditional engineering shop for blockchain, a high-frequency trading firm, and saying like, hey, you guys, there's this old sort of like adage in TradFi trading, which is you can be smart or you can be fast. And if you can only choose one, you want to be fast. Right? Because smart is hard, right? Smart is like Rentech and Millennium Fund. Fast is just engineering. Like you can have a bunch of like B+ tier quants, and as long as your engineering is the best in the industry, you're going to make more money than other people. Because like you'd rather have 10 basis points on $300 billion of volume than like a few magic trades that are just excellent, right? And so going to a trading firm and being like, you guys focus on performance, like how do you look at rewriting a validator client from a performance first architecture? And one of the things that we found, we sat down with a bunch of the engineers who now today are building Firedancer, is they're like, there's a lot wrong with the Solana code base from a performance standpoint, but it's the least wrong of any chain out there. So we feel like we can make a lot of progress on this. Like little things like the fact that you have to specify all the accounts you want to talk to in a transaction, huge benefits for performance. Like otherwise you're dealing with stochastic modeling, and like Monad's gotten into this where like there is an overhead in Monad that is very similar to the overhead in like the Intel like Pentium 4 days of hyperthreading of like at some point the pipeline is going to guess wrong and you have to go back up to the top of that pipelining stage and restart because you guessed really well but you guessed wrong. And so that's where like Solana and the SVM has a really strong advantage from a foundational standpoint. That being said, there's nothing that prevents you from doing this for Ethereum stuff too. Now, does Ethereum and does that world maybe have to get EVM 2.0? I mean, there's a whole bunch of new stuff going into Monad that is not in EVM canonical, right? And that's super interesting to me. There's a bunch of stuff being done on like Mega ETH around just inclusion and not cranking execution. Super interesting. I'd love to see where that kind of goes in the future. And with Solana too, there's all this work now on Firedancer, 00, like IBRL as this mindset that, I think if you follow like Alessandro on Twitter, you see him like posting about like, oh, we just like we updated the TPU and now it can handle 10x more capacity than it could in the previous release. Like these optimizations, like the only way you eat an elephant is one bite at a time. The only, Andel's law, the only way you make a system faster is you upgrade every single component of it. And then the whole thing has this like waterfall moment of increased performance.
So in a way, when we talk about, we increase bandwidth and reduce latency, I feel there are two parts to the puzzle. One is increasing bandwidth. When we speak about increasing bandwidth, is it network bandwidth, or are we speaking about bandwidth in terms of the number of transactions you could process? That is number one. And reducing latency, I think that is it is reasonably legible in the sense that you can shave off latency from every component in a large architecture, and that's legible. But what do we really mean when we say increasing bandwidth?
Yeah, so I think these mean two different things depending on which engineer you're talking to. So 00 is not a blockchain, strictly speaking. We are building a OSI layer 1, 2, 3. Like blockchains are like 5, 6, 7, right? Like we're building much lower down in the stack. And what we are focused on when we talk about latency is real latency, the time it takes packets to get from point A to point B. What we're talking about bandwidth is real, like how fat are the pipes? Not how much block data you're sending over it, but like what is the theoretical maximum amount of data you can pump through this piece of glass. And from there, that's where all the software optimizations come back to. But like when we go to IBRL for like, let's say like the FireDancer team or the Agave team or the 𝗼𝗀 team, it means maybe something a little bit different. So, you know, we've seen CU limits raised by about 4%. Like it's not much of a raise, but it's a good start, right? But also 4% every month is a hell of a lot over compounding, not interest, but compounding CUs, right? Like we're going to get a lot more capacity through these systems soon. But when we're talking about, you know, increasing bandwidth from a transaction standpoint, there's like a bunch of other components that go into that. So for example, if all we do is start increasing block size, right? Okay, now there's more data available. Great. Can the validators actually efficiently process that data? That's a question. FireDancer can. Agave's getting there. Another thing as we look through this is, what about all the other stuff that has to happen? Like people forget about this a lot when they think about blockchain. Turbine is like a marvel of modern distributed system engineering. The fact that like we have this massive fan out where shreds are propagated in almost real time out to the rest of the network. You know, basically when it hits the MTU size of like the packet spec for Solana, which is like 1358 maybe, I can't remember exactly. It's less than your standard MTU size to leave some overhead for some other stuff in it. Those packets go out, like, and that fan out gets state all around the world incredibly quickly. There's no other network that is anything like Turbine. But Turbine is incredibly bandwidth heavy, right? These nodes are very gossipy, right? We also have a protocol called Gossip, which is pretty gossipy too. But like the reason we talk about these things as problems, if you saw the demo of a FireDancer client with 6 nodes globally distributed running 1 million TPS, that was about 2.3 gigabytes per second of data that it was taking up to do that. And a lot of that is like even on just a 6-node cluster, that's state propagation too. Right. And so when we look at these types of things, there's this old sort of adage in engineering that like, which is very similar to something Tolle used to say, which is you haven't solved scaling if you can't throw more hardware at it. And like there is a form of traffic engineering that like some bandwidth providers go through where you just throw more bandwidth at the problem. Right. And so the easiest thing to do is just to say, if we wire up every Solana validator with 100 gigabits of connectivity, we can make no protocol changes and just start raising limits and things will go great. But that's not like the right way to engineer this stuff. So if you go back to like the HFT space, multicast is a technology that's been used for years. Now, multicast, the easiest way to explain multicast is if you have a bunch of Sonos speakers or AirPlay devices or Chromecast or something like that, and you want to play music to multi-room audio, your phone is not sending out 5 copies of the song that's going to all of those different speakers. It's sending out 1 copy of it, and your router is saying, hey, this is a multicast feed. Who wants this multicast feed? And all the speakers are saying, send me the data, send me the data, send me the data. And so the replication is handled at the hardware level. It's not handled at the software level. And so we can bring, and multicast has been used for years in high frequency trading like firms and engineering because it's a really good way to get data to multiple places, right? The easiest version of this is like, we want 2 redundant systems. So we need to send data to the active system and the 2 backups, but we don't want to waste a bunch of time sending the data 3 times. So the switch is just going to replicate that data for us. And so if one system goes offline, the backup system already has all the data because it's been receiving it throughout the course because it's all hardware accelerated in the switch and it's very, very quick and easy to do. We can do that for things like state propagation. So instead of a validator having to fan out and send to a bunch of different addresses when it builds a block or sends a packet out, it can just send that packet to the network switches. And the switches say, oh, this packet is going to this multicast group. We're going to replicate it automatically across the entire network and deliver it to everybody who has put up their hand and say, hey, I want these packets about Solana state transitions. Now, those packets can be going to validators. They can be going to read-only endpoints, like maybe a Dune ingest server, so they're like pulling data in more quickly. All these types of things. It also removes one of the major issues today with Turbine, which is it's stake weighted. right? Now, stake-weighted turbine makes a ton of sense if what you're worried about is building the next block. If what you're worried about is forming a transaction and sending it on the RPC layer, like, good luck, you're getting your turbine data stale. Now, the way around that are things like Shredstream, which Jito has built, which, is basically an alternative to Turbine. But, Shredstream is pushing gigabits per second of data through when it really doesn't have to. And it is doing this because it hasn't yet been optimized for these types of things, especially with multicast and those sorts of technologies. So this is a very long answer to your question about what do we mean when we talk about increasing bandwidth. It really depends where you look at the stack. But the way we at 00 think about this is if you don't solve the problems as close to the hardware or in hardware as possible, you're always building on a shaky foundation. And, this has been the Solana thesis forever. This is a big thesis I was kind of a big proponent of when I was at the Solana Foundation, which is we should be building technology in as generalized an application as possible and as low level as possible, right? We shouldn't build compressed NFTs. We should build compression. And then Metaplex will build compressed NFTs, right? We shouldn't be building, everything. For example, if you go down to like Solana and its core layer, you can write a front end for LLVM in any type of programming language you want. That's super powerful. That means like if Rust is out of favor in 10 years, someone can just build a different front end for a different thing, right? The C tooling needs a little bit of work. Like there's lots of caveats there, but there was a whole project for a while to build a Move front end for Solana, which would not necessitate adding a second VM to support Move. That's super cool, right? But like this whole philosophy of like build things as generic and as low level as possible, we've really taken that forward with 00, and that's why it's a physical fiber network, right? We're not talking about like software abstraction layers and like software routing systems that don't actually run on the physical fiber layer. We have that stuff too, but if you don't start with a physical network, all the rest of it, like you're always running up against a performance bottleneck of the base layer.
It's awesome. You mentioned 00, right? So when in the paper you mentioned this like two-ring architecture where you have an outer ingress and egress ring, and then there is also an inner data ring. So is 00 like some kind of a metaphor to these two rings?
Oh yeah, totally. The name, like all bad or good names, you just like eventually call the code name the product name because you can't think of anything better. Like maybe in a few years we'll rebrand, who knows? But like I kind of like 00. It feels different from a lot of the other industry naming conventions at this point. So.
And also you were talking about this. For example, increasing bandwidth by pushing all the data flow to the hardware level. So could you talk a little bit more about like what really happens in this inner data flow ring? Is that where the gossip is expected to go?
Yeah, totally. So today what happens is Solana validators have, and other validators as well, have one IP address, right? There's a second IP address being added into the gossip protocol, so validators can basically have a inside 00 IP address and an outside 00 IP address. You can think about this as like they're sitting on the border, right? One leg is in France, one leg is in Spain, and so the reason we're doing this way is the way that a validator will actually interface with the 00 network is not by plugging in a cable, right, to a switch. Because you remember, at the end of the day, this is a physical fiber network. So there is a physical fiber line going from a switch through a bunch of things out connected to other switches elsewhere in the world. But if you're running a 00 switch and every like one in the data center is like, hey, can I plug into the front of it? Like it's a cabling nightmare. It's a whole mess from an admin perspective. And networking technology is a little bit like printers, right? Like no one ever wants to touch the printer. Like the first thing you do if you ever had like an IT job in like college or high school is get someone else to deal with the printer, because everyone's like, oh, printers are IT, and you're like, no, printers are different, right? Like cabling is the same way, right? It's like all these like software and high performance engineers are like, yeah, this is great, but like we really don't want to touch any cables. So the way around that is you basically create software tunnels within the data center or the environment that the validators are operating that create a GRE tunnel from the validator to the switch. Now, in something like TerraSwitch, that's just going to be a local network connection over the LAN, effectively, the internal network of the data center. And so it's super fast. It's not like HFT firm fast, but we don't care about 50 microseconds when we're dealing with these types of things. This is blockchain. We're still not anywhere near like that level of care. And so from the validator perspective, there's basically two interfaces now. One's the physical hardware NIC, and the second is the tunnel interface. And that tunnel is how it communicates with the switch, which is where the tunnel endpoint basically goes to. Now, these are not like your normal $200 like switches you have in your house. These are like large switches that are, designed for like these type of like basically, trading applications. And inside of it, they have like two large Xilinx FPGAs. And the FPGAs will do things like signature verification in hardware, transaction deduplication in hardware, and a bunch of other things in hardware over the long term. And the nice part is because they're FPGAs, not ASICs, we can tweak them and change them over time and evolve what that looks like. But by offloading the spam protection layer as well as the transaction verification layer, what we're making sure is validators are only receiving basically cleaned and filtered data. Now, spam transactions, like there's a whole definition of what's a spam transaction. Our only definition of spam transaction is the packet identical, and do the signature, if the packet's identical, you throw it out. If the signatures don't match, you throw it out. Now, it still could be a spam transaction in the sense of like it's a very low economic value transaction. That's not our job on 00 to care about the economic value. It's literally like, is this transaction conforming to the spec that Solana says it needs to, or Ethereum says it needs to, or whatever kind of comes from there. So from the data flow, then once you get into the switch, that's when you're effectively on the 00 network. And so if let's say that I am a validator broadcasting data out, and this is before Multicast, I am communicating over 00 the same way I would effectively communicate over the internet. Except instead, I know the internal 00 IP address and the external IP address of a server. And so, at that point, you're like, oh, I'm going to talk to it on the fastest connection. And so that's going to always be over at the 00 network if the other validator is located on 00. If I'm an RPC, what I'm doing is I'm sending traffic in through the 00 network to get routed to wherever the leader happens to be at that moment. And latency is a compounding advantage, I would say. So, right now in Solana, there's a little bit of round trip that has to go, because if I'm sending from an RPC provider, I'm proxying my transaction through a staked validator. That's one network hop. Then there's another network hop to catch up to wherever the leader is. So if we're dealing with, two hops at that point, if 00 is, 40% faster, 20% faster, even 10% faster than the public internet over a given link, that's where you start to see real advantage in terms of performance. But the bandwidth increasing and the latency reduction is actually only a part of it. Like, if we really want to be technically accurate, we're increasing bandwidth, reducing latency, and reducing jitter. And jitter is sort of like the silent killer of high performance systems. Like, people don't think about jitter much. Jitter is a measurement of basically like the variance in latency time. So if I ping a server and it's always 100 milliseconds, the jitter is 0, even though the latency is 100. If it goes between 80 and 150, then the jitter is super high. And when you're dealing with really high jitter, what it does is it basically throws everything out of whack. You can think about it as like, I'm feeling like a semi-trailer and I'm packing stuff into it. But if the stuff you're putting into the truck doesn't arrive in order, you suddenly need a giant buffer. You need a whole waiting area where you can load stuff into the waiting area before you put it into the truck. And so if what we're doing is something like Solana Turbine, right, where like data is coming off in real time and folks are basically rebuilding blocks in real time, yeah, you can leave a gap and say, okay, I know I'm missing a piece of data here. When it arrives, I'll drop it in this place, and we have erasure coding and all sorts of things to make that like faster on Solana today. But if everything just arrives in order, so much time can be saved, like processing time can be saved. And that's one of the main advantages of 00 is the jitter reduction.
That's very cool. Super interesting. This seems like so you're building on top of other blockchains, and seems like it's like another network that eventually everyone would want to use or would be forced to use because it'll be more performant.
Yeah.
So my question is, as a blockchain validator right now, are you guys writing your own client? Are people expected to migrate to a different client or just change a few configs to be able to join the 00 network?
Yeah, so the way we sort of are doing this is we are not building a validator client. We are working with, Anza on Agave and Jito on their Jito client and Firedancer team on the Firedancer client, because we don't need to build our own client for this, right? Like a lot of the stuff that we're talking about, there's right now our conception of how this works, and we have a private testnet up and running. There's 4 Solana mainnet validators building blocks running on 00 today. We have a CLI toolkit that you download and that does a few different things. So one thing is it tells the client basically how to talk to one of these network interfaces. Now, the tunnel interfaces, now that's getting built into all of the clients. That won't be like a feature that's needed. But we actually have the first network that provisions IP addresses and routing based on smart contracts that anyone's ever built. We've done a bunch of research to make sure this is actually true, but no one's ever built a network before where I can obtain an IP address and I can obtain route access through smart contract. So we have a private cluster of it is a blockchain, but it's not a blockchain anyone would deploy smart contracts on. It's really just a distributed ledger. But you interact with a contract and you basically say, hey, here's my validator, here's my address, here's my validator identity. You create an identity on this thing of 00, and then it provisions you an IP address. And that IP address becomes attached to the tunnel. And that is how you interact with things through this. So, we are not looking to, we're not looking to build a client. We don't need to build a client. There's many people who are much better than us at building clients. What we're really good at is this low-level networking work. And so that's what people will be interacting with in order to join the 00 network.
Got it. That makes sense. You also mentioned you'll have to install a bunch of these switches that HFTs use. So is there a hardware challenge in what you're building?
Yeah, there's 2. So the first one is the switches. The second one is the physical fiber in the ground, right? Or running under the oceans. And so software networks are sexy and easy because all you have to do is tell people to install some software on a computer. Right. That's great. That's easy. That's nice. We need to physically get things connected, and we need hardware, and we need hardware at certain locations, right? Hash power for Bitcoin, completely swappable. Right? They're completely comparable goods. Hash power from one miner is just as good as hash power from another miner. Validation from the Coinbase validator is just as good as validation from the Kraken validator or, the Chainflow validator or whatever. That is not the case with 00 because this is a physical locality-based network. This is part of why I've harped on DPIN for a while about getting really wishy-washy on oh, it's just compute resources. That's not DPIN at that point. That's just a blockchain, man. I get it that you're rendering GPUs and AI workloads, but that's not DPIN. That's just an application-specific blockchain. Helium is DPIN because the location of the routers and all these other things, it intricately matters. You can't avoid location when it comes to this stuff. So because bandwidth is not compatible, your bandwidth in California does me no good if my server's running in New York. We have to think about these things in slightly different ways. So the switches are expensive. They're not cheap. The fiber is also expensive. It's not cheap. But we went through this transition when we moved from, the idea of I can run a Raspberry Pi in my basement and I can participate in a network to, I need to spend $700 a month and get a server somewhere, or I need to build a server and I have fast enough internet at home to be able to run it on. All modern blockchains have extremely high performance requirements. And Solana actually not the highest requirements. People think it's the highest requirements. It's not. You should go look at how heavy a validator on another type of network is, let alone how heavy a sequencer is. But all these things kind of get back to this idea that you do need these networks built out, and it's going to be something where we have no conceptions that the average normal user of any blockchain is going to be able to operate a 00 endpoint. These are things that are going to be run by professional operators, the same way that the internet is run by professional operators. Like, you can technically run your own mail server. No one runs their own mail server. Everyone just uses Gmail or Proton Mail or something like that. You can technically go build your own internet and wire up, your neighbors and have your little IRC chats. No one does that, right? And so what we are trying to do is not make 0.0 something that everyone can run, because it's just not possible today. Maybe in the future with satellite clusters, it'll be different. What we're trying to make sure 0.0 is sufficiently censorship resistant that it has basically the same resistance profile as the public internet today. Now, that may seem ambitious, but there's actually only 20 companies that run the tier 1 ISPs around the world. If those 20 companies gang up on you, you are not getting global transit of data. Now, there's lots of other things. There's Cloudflare involved in things. There's lots of other components that go into that. But at its core, what we are trying to build is a prioritization layer and a high-performance network for all high-performance distributed systems. And who knows, someday maybe that is not exactly a competitor to the internet, but it's some form of alternative to the internet.
So just to double click on that, right? You mentioned that you actually need to physically manipulate these fiber links to form this network, right? And what does it really mean? Is it are you going to dig trenches in the ocean and then connect it, or someone already has or it's ISPs with access to backhauls that that onboard onto 0.0. Sorry, not backhauls, backbones.
Totally. So it's a good question. I would say over the long term, our ambition is that the foundation probably does own and build infrastructure. However, in the early days, the easiest thing to do is to use excess capacity. So there's many types of excess capacity. The type that's most readily available are from companies that run their own networks today. So lots and lots, there's thousands of companies that actually have their own networks, whether they're global or whether they're regional is a different question. But if you look at like a high frequency trading firm, like Jump Trading is one of the first contributors to the 0.0 network. They're contributing a 10 gigabit slice of their global data network. Now, their network is optimized for all sorts of things internally, but what they're able to do is segment off just 10 gigabits of that and hand that over basically to 0.0 by installing these switches and setting policies on their network for this. We have other firms, contributing data as well. We're getting pretty close to 100 gigabit network build out, around the world, which is more than enough for all of today's blockchain traffic. We can get back to that, as well in the future. We have other types of folks contributing network capacity as well. We actually are working with one node and network provider in Europe to build out sort of European connectivity into a bunch of cities and data centers across Europe. And so, when we look at this now, it's a lot of shared infrastructure. Over the long term, when the economics of the network are built out enough and support it, we imagine there'll be a lot more dedicated providers spinning up. But these leases, like if you're talking about like a monthly lease on a piece of undersea fiber, that can be as little as $3,000 a month, and it can be, if you want Hibernia, it can be $300,000 a month. Now we don't need the HFT grade, fastest out there network links to make this work. We can use the sort of like the stuff that's maybe like the second fastest or third fastest or fourth fastest provider, because it's still way faster than the public internet, and we solve the jitter problem, and we can use these technologies like multicast. But yeah, you fast forward and this protocol is worth, a fifth of what Solana's worth someday maybe, and you better believe we're looking at launching satellite networks and joining cable consortiums and all those sorts of things too.
Wow. Yeah, this sounds super ambitious and also extremely hyped about what 0.0, what the world will look like when 0.0 is fully out there. With that, I think what would be so interesting to our listeners is how do people get involved with you? Are you hiring for any roles? And what are your biggest challenges today that people could step up and help you on?
Let's see. So I think there's a whole bunch of different types of things at different layers of the stack, I would say. So one of the things that is great about blockchain is we always reinvent the wheel. One of the things that sucks about blockchain is we always reinvent the wheel. So we talk to a lot of engineers across the board who really don't know anything about how high performance networking works, right? Even if they're working on a high performance blockchain. Like, you saw the episode probably of Bankless like a few months ago where it was sort of 𝗜𝗺𝗽 and Bing talking about, and Lei talking about, oh, we're rebuilding databases for higher throughput performance systems. It's like, yeah, that's super important. You've got to do that. But if you don't address the networking layer, you've got the Kevin Bauer's famous analogy, you've got a Ferrari stuck in traffic. And just because that Ferrari can go 220 miles an hour doesn't mean it's going 220 miles an hour. And that's kind of one of the main pieces that we are trying to get more people to understand. We're trying to get more folks to think about. The thing I kind of keep saying is like the ambition of this industry is still very small. The fact that people are excited about 100,000 TPS or even 1 million TPS and like think that we've accomplished something at, 10,000 TPS on Solana or, on some other networks, the ambition is just way too small. Like if this, like the world computer is like back in vogue, right? Like ultrasound money's gone, the world computer's back. Like it's great. I think the world computer is an incredible vision. The world computer needs 10 million transactions per second. And it doesn't need them through a bunch of L2s that are all doing 400 transactions per second. It needs L2s that are pushing 1 million transactions per second. It needs the base layer to probably scale up as well. Like there's all of this type of stuff that the minute you get into it, you're like, oh, if we actually for a minute take the rhetoric seriously, we are so far away from any type of capacity. Even on Solana and Sui and like the fastest blockchains out there, we're probably 10 to 100 orders of magnitude away from remotely being able to address those type of needs and demands. And you can't get there if you don't address the base layer. Like people forget that like Facebook literally wired up the Philippines and India with a bunch of fiber so they could sell people ads. Like at some point, these companies, all these big tech companies, like even the cloud providers that are like, oh, we're just virtualized data centers. Like we don't want to touch hardware. They all own fiber nowadays too. Like Netflix owns fiber. Like the public internet is an incredible resource, but it is not built for the type of scale and performance that folks need from this type of stuff. And so if we really want to start competing with the banks, we really want to start competing with these like centralized like systems, you really want permissionless, open, decentralized AI to become real and not just a bunch of like kind of shitty reply bots on Twitter. Like we actually need connectivity between these things. Like Microsoft is running terabits of connectivity between the data centers they're building. Like talk to any decentralized training AI company out there and they're like, yeah, we waste so much time on network transit. We waste so much time on snapshot resyncing, on all these types of things. And so I think like the sexy thing to do is always to rush to the new technology on the application layer and try and build something there. But, you got to put in the hard work of like building that low level capacity. So we're hiring. This is a long way of saying we're hiring. If you go to 00.xyz, there's a whole jobs board there. And, if you are an engineer working on a protocol and you're inspired to say like, we really need to start thinking about what performance looks like when we hit scale. Let's talk, right? Like the 00 started as a Solana first project, but we're in no means a Solana only project. We're nailing Solana first because the need is there with FireDancer. The product market fit is there with Solana as well. And, as we go faster and faster, like Solana's the hardest one. If we can nail Solana first, everything else is downhill from there. The only thing I was gonna say is like, I think the energy space is super interesting and like it goes hand in hand with this. The challenge is it is regulated up the wazoo. And one of the nice things about private networking is it's a much more regulatorily clear space. And so it feels like it's an area like Godspeed Meltem, like go hard on nuclear for 5 years and like maybe someday we'll be able to build like decentralized power systems. I think Sourceful's been doing some interesting work on that with battery backups, mostly in Europe. But the nice thing about the networking layer is it's an area where there's enough regulatory clarity that it can be solved today. And that's kind of why I think that's like, I wouldn't call it the low-hanging fruit because it's a very ambitious, difficult technical project, but it is the one that feels like it's the next thing we have to nail. Like we've kind of fixed the compute problem in blockchain. The networking problem's the next one.
Awesome.
Cool.
Thank you so much, Austin, for joining. It was great talking to you.
Yeah. Thanks, guys. Appreciate it.
Sweet.
Bye bye.
Bye.
Bye-bye.